Welcome to the session on operating system structure. In this session, we will understand about the simple operating system structure, layered approach, microkernel, modules, and hybrid structure. Simple structure. The MS-DOS written by Bill Gates, written to provide the most functionality in the least space, not provided into modules. Although MS-DOS has some structure, its interface and levels of functionalities are not well separated. Here you see MS layered approach, ROM BIOS driver is in the bottom layer, then MS-DOS device drivers, then resident program, and then finally application programs. So built on ROM BIOS, MS-DOS device drivers are built, and above device drivers, resident system program, and top application programs. These are the various layers of MS-DOS. Traditional Unix structure. Unix limited by hardware functionality, the original. Unix operating system has some limited structure. It consists of two separate parts. One is system program, another one is kernel. You see this diagram. This bottom one is the hardware and the middle kernel, that is the heart of the operating system. And the above are system programs or the applications. So the kernel is the heart of the operation system. It has system, signal, terminals, file system, and so on, everything. This system call acts as an interface between the application program and the kernel. Kernel acts as an interface between the system calls and the hardware. So this is the structure of traditional Unix operating system. Layered approach. This is another interesting approach of a Linux based system. The operating system is divided into a number of layers or levels, each built on the top layers. The bottom layer or layer number 0 is the hardware. Here this will be the hardware usually. In Linux environment, the innermost layer 0 will be the hardware. The second level 1 will be the kernel, and level 2 will be the shell or interface, and level 3 will be the user application program, and then user. So like that, the operating system will be divided into different layers, and each and every layers are interact with the other layer user. For example, hardware will be interacted with application program through kernel, and application program interact with the kernel through or user interact with the application program using application programs. So these are the way the operating systems interacted. Microkernel system structure. So this microkernel system structure moves as much from the kernel into user space. Communication takes place between the user modules using message passing. It's easier to extend the microkernel, easier to port the operating system to a new architecture. It's more reliable, more secure, so it is very convenient for converting operating system from one architecture to another architecture. Here you see application program is in top, then system call interface acts as an interface between the application and the user programs, and then the user area is divided by dashed line. So above this one, these are all user areas. Bottom is the kernel area or the heart of the operating system. In kernel we have IPC tools. Using IPC tools, the user space and kernel spaces are communicated. What do you mean by IPC tools? Inter-process communication tools. Using that tools, the kernel data will be communicated or transferred to the user space and vice versa. Modules. Most modern operating system implements kernel modules. So this is the core Solar is kernel. It has different modules. Uses different object-oriented approach. Each module component is separate. Each talks to each other over some interface. Each is loadable as needed within the kernel. Overall, it's a similar layer but not more flexible, so it is independent. They are all communicated with the separate modules. Scheduling classes, file systems, loadable system calls, executable formats, streams modules, miscellaneous modules, device and bus drivers. These are various Solaris kernel modules. Hybrid system which consists of both a layered approach as well as the module approach. Many operating system combines different structure as hybrid system. Hybrid system addresses performance, security and usability. So some operating system includes the MS-DOS, the layered approach, the module approach, everything clubbed together as a new structure. That is hybrid system. So the Mac OS structure is one of the things. So the Mac you see here, application environments is interfaced with the BSD, Berkeley Software Development layer, and Mac kernel. So these are the different layers of Mac OS. Here when you take about the Google Android OS, so top layer is application, then application framework. Between application framework and Linux kernel, we have libraries and runtime libraries, ordinary other libraries and runtime libraries. So these libraries are SQLite, OpenGL, Surface Manager, Media Framework, WebKit, libc, and Android runtime libraries are core libraries and Dalvik virtual machines. These are the things placed between application framework and kernel. This is a Android layer and this is Mac OS layer. Hybrid system models. Break for questions. Let's examine ourselves with some questions. Which of the following is the heart of the Unix operating system? Kernel, cell, hardware, application, which one? The answer is kernel. Answer A, kernel. Kernel is the heart of the operating system. The second question. In which structure the communication between user and kernel is happening through IPC? So the communication between user and kernel happening through IPC in monolithic, microkernel, layered and modules. In which one? In microkernel model structure, the communication between the user and the kernel happens through inter-process communication tools. So in this session, we understand about operating system architectures like microkernel, layered approach, module approach and hybrid systems. Happy learning. Thank you.